press the bell icon on the YouTube app and never miss another update.
Hello dear students, so let me continue part 15 lecture from work, energy, power. So anyhow, up to the part 15, part 14, I have covered so many variety of concepts, and by using those concepts, let me continue some problems. Anyhow, we already sent an assignment to you, okay, that consists of some number of questions. So let me select some good level of questions from assignment sheet and let me solve some problems from that. Okay, now see the assignment sheet. Let me cover few questions. See one question. They given a projectile is fired on a horizontal ground. Coefficient of restitution between the projectile and the ground is small e. If a comma b comma c be the ratio of the time of flight, maximum height, horizontal range in the first two collision with the ground, then a is equals to 1 by e, b is equals to 1 by e square, c is equals to 1 by e. Now let us see which one is true, whether a and b are true, or b and c, or a and c, or abc, all are true. Now let us see the solution of this. So anyhow, in the last sessions we know coefficient of restitution. Okay, so a ball is thrown by making some angle theta. We covered T1, T2, everything, and after the first collision we know the velocity of the ball becomes e times of the initial velocity. So according to the question, see they given for two collisions. Now there is a given projectile is fired like this, and this is the first collision, and this is the next one. Okay, time taken by this one is t1 and this one is t2. Let me verify all the things. And this is the range. Already same concept is covered in the last video classes. So t1, t2, and this one is h1, h2. We know if it is projected with a speed u, then after the first collision it will come out with a speed e times of u. We know these things in previous classes. If a ball moves with a speed u, after the first collision it will come out with a speed eu, next e square u, e cube u, it will continues. Now let me verify what is that t1, t2. So let me write directly now t1 by t2. Let me write t1. What is t1? 2u sin theta by g. t2, 2 u becomes e times of u. So e times of u sin theta by g. So sin theta 2u sin theta 2u cancelled. It is equivalent to 1 by e. Anyhow, they given t1 by t2 value is 1 by e. Let me verify maximum heights h1, h2. We can expect directly maximum height proportional to u square. So we can write directly. Otherwise, let me write u square sin square theta by 2g. Here u becomes eu. So e square u square sin square theta by 2g. If you strike off, you will get 1 by e square. Okay. In the same manner, let me find r1 by r2. r1 by r2 range. So range is nothing but u cos theta into t. Okay. Otherwise, u square sin 2 theta by g. Here u becomes again e square u square sin 2 theta by g. See, if you strike off these values, you will get 1 by e square. See, in the given options, small a is given 1 by e, small a is 1 by e, t1, t2 as a small a, yeah, this is correct. Small b was given e square, yeah, this is small b, so this is also correct. Coming to the c is range, so I am getting 1 by e square, but what they given? 1 by e. So I am getting 1 by e square, they given 1 by e. So out of all the options, Only A, B are correct. So first option is the correct answer for this question. Okay. See the next. Yeah, this is also a good question. A particle of mass m is hanging from a string of length, and a particle of mass 2m is just moving horizontally, strikes m head on elastically. If m just completes a vertical circle, the velocity of 2m before the collision is. Okay, just read the problem. So let me see the solution now. They given a particle of mass m, particle of mass m hanging from a string of length. So let us suppose L is the length of the string. See, this is the particle whose mass they given m. Particle of mass m and length is, let us suppose, L, because in options there is a L. And another particle of mass 2m moving horizontally, and that is going to strike m head on elastically. So another one is 2m which moves horizontally with some speed u. Okay, and it is going to strike the particle of mass small m. If small m completes a vertical circle, we know vertical circle, this is also covered in the previous classes. Vertical circle, if a body wants to complete a vertical circle, definitely the velocity of the body at the lowest point is what? Root phi g r. I hope you remember the formula. So to complete a vertical circle, then the minimum velocity at the lowest point of the vertical circle is root of phi g r, where r is the radius of the circle. Here r nothing but L. So root phi g L. To complete a vertical circle, the velocity of this one after the collision is root 5 g L. Now let me use a simple formula like conservation of linear momentum. What is the conservation of linear momentum? m1 u1 plus m2 u2, which is equivalent to m1 v1 plus m2 v2. What is m1? m1 is 2m, u1 is u, m2 is m, and initially it is at rest. So u2 0, m1 2m, okay, v1 plus m2 nothing but m, v2 nothing but root 5gl. Got my point? v2 is what? Root 5gl. Okay, and let us find this v1 value. How to get the v1? v1 is the velocity of the body, velocity of the first body after the collision. What is the formula for v1? I hope you remember the formula for v1. v1 is equals to m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. 2m2 u2. What is u2? What is u2? u2 becomes 0. Then no need to write here 0. So v1 formula is this. What is m1? 2m. m2 m. m1 plus m2 3m into u. So this is m cancelled, it is u by 3. What is v1? v1 converted into u by 3. So where v1 is there, you write u by 3. 2mu 2mu by 3 plus m root 5gl. So strike off m on both sides. 2u, right side 2u by 3. Take 2u by 3 left. So let me write 2u minus 2u by 3 root 5gl. Target is to find out u. This is 6 minus 2, 4. 4u by 3. 4u by 3 root 5gl. So u is equals to 3 by 4 root 5gl. Now tell me which one is correct. 3 by 4 of root 5 GL. So first one is correct option. See the next question. "50 kg of sand is deposited each second onto a conveyor belt moving at 5 meter per second. Then they are asking to find extra power required to maintain the belt in motion is." So anyhow this concept also covered. So 50 kg of sand is going to deposit each second onto a conveyor belt. Conveyor belt concept already covered. Anyhow we know power nothing but what? Force into velocity. So power is nothing but force into velocity. We can write power is force into velocity, and something is dropped on a conveyor belt like a sand. I used a word in a concept is sand is dropped on a conveyor belt, so that the belt is moving with some constant speed. Okay, some sand is dropped, like this is a dm by dt, rate of sand, rate of mass. Here we can write f as dp by dt, and here the belt is moving with constant speed, then dp by dt, p nothing but mv, momentum. So d by dt of mv into v. So already these formulas are covered. V dm by dt into v. So v square dm by dt. What is v? They given belt is moving with 5 meter per second. 5 means it is 25. dm by dt, 50 kg sand on each second. So 50 kg by second nothing but 1. So 5, 25, this is 1, 2, 5, 0 watt. So very simple question, this is 1250 watt. Okay. See the next question. Yeah, good question. Next one also. See, they given some graph. Let us see what we have to find. A particle is acted upon by a force capital F, which is varies with position x as shown in figure. If the particle at x is equals to 0 has a kinetic energy 25 joules, then what is the kinetic energy of the particle at 16 meter? Anyhow they given a graph, and see, kinetic energy at x is equal to 0 is given, means initial kinetic energy is given. Target is to find out final kinetic energy. And anyhow we know from work energy theorem, we know work done by a variable force which is equivalent to change in kinetic energy. So work done which is equivalent to change in kinetic energy. And we know area under force and displacement, force and position, force and displacement will give work done. So first of all you try to find out work done by using the graph. Okay, so work done by using the graph you find it. Anyhow from work energy theorem we can write kf minus ki. What is this work? This is the area under fs graph, area under fs graph, kf minus ki, final kinetic energy minus initial kinetic energy, area under fs. See the graph, f and s. See the first one is like a triangle, so half into base into height. You know how to find out the area under the graphs. So half into base is 6 and height is 10. So 6 into 10 plus, sorry, downside is there, put a minus, and the size of the second one is like a square, that is 5, and 10 minus 6, 4. So 10, sorry, here 5 and 4 plus again the same 5 and 4. You know how to find out this area of the square. And the last one is 14 and 16 is the base and height is 5. So 2 into 5 kf minus ki is given 25 joules. Anyhow 5 into 4, 5 into 4 cancelled, 2 3s are, this is 30 and 10, 30 minus 10, it's 20 kf minus 25, so kf is equivalent to 45 joules. So 45 joules is the answer. Okay, yeah. See the next question. Yeah, go for the next one. So next question based on again collisions. An elastic ball is dropped from a height of 12.6 meter above a smooth horizontal floor. Find the time taken before the ball completely comes to rest. Okay, so see, already we know when a ball falls from a height h, we know the height of the body after first rebound, height of the body after second rebound. In the same way, we already calculated time taken by the body after first rebound, time taken by the body after second, third, so on. And we know one shortcut formula, time taken by the body before coming to rest on a floor. I hope you remember the formula, and these derivations also covered in the last concepts. So let me write formula 2h by g 1 plus e by 1 minus e. Then answer is nothing because e value is given 1 by 2. Now t is equals to root of 2 into 19.6, this is 9.8, 1 plus 1 by 2 e is given 1 minus 1 by 2. So this is 2 2 to 4, it becomes 2, and 1 plus this is 3 by 2 and this is 1 by 2. So answer is 6 seconds. It is going to comes to rest in 6 seconds before coming to rest. So simple question. If you know the formula, it is good. Okay. Yeah. Next one. So next somewhat good question this is based on some vector representations. They given 3 masses m, 2m, 3m are moving in xy plane with speeds 3u, 2u, u respectively as shown in figure. The 3 masses collide at the same point at P and stick together. Okay, see in a question they given arrow marks are little different. I will draw the correct picture. The velocity of the resulting mass is, see the actual diagram, they given some arrow mark little different, they given up, but actually all the 3 particle has to collide. So all the 3 particle has to collide at P means arrow mark should be along the direction of P, along the P. Okay, see this is the point P, one particle is moving towards the P, so give the arrow mark like this. What is the mass of the particle? M. What is the speed? It is 3 times of u. And another mass, see the arrow mark in this direction, they given opposite, so you change the arrow mark direction. This is 2m mass moving with 2u and makes an angle mentioned already 60 degrees. This is also maintained some 60 degrees angle, and this is 3m mass and u. Okay, this is x axis and y axis. See they given three different masses m, 2m, 3m. All are going to meet at a point P, but 2m makes some angle 60 degrees with x-axis. 3m makes an angle again with 60 degrees with x-axis. So definitely we have to resolve these mass and velocities into some components. Okay, they are asking the velocity of the resulting mass, and each and mass moving with some speed u. So each particle have momentum. Now the net momentum we can write by using vector addition rules. We can write the total momentum in vector form. We can write it as p1 bar plus p2 bar plus p3 bar. Okay, if any another particle is also moving towards the p, again you follow the same thing. So p is the net momentum, that can be written as p1 bar plus p2 bar plus p3 bar. And see the first particle. Let us suppose this is p1. Okay. This is p is equals to p1. p1 means it is moving along a positive x-axis. So positive x-axis means we know it can be represented as I cap symbol. Positive y-axis means plus j, and negative y means minus j. Positive z towards u plus k, negative z into the board minus k. You know these sign conventions in vectors chapter. So let me write all these values by using vector notations. And the first particle moving with a speed 3 times of u along the positive x-axis. So along the positive x-axis means we have to represent the momentum with an I cap symbol. So first one is not a problem. So mass and velocity is m and 3u I cap plus. So the first one completed. Second one, second mass, second momentum. So anyone you take the second one. Let us suppose 3mu I am going to take second one, and resolve this 3mu momentum into two components. See, the particle is moving towards in this way, towards the point P. Okay, see the arrow mark in which side it is there, and resolve this 3mu into two components. One component is like this, 3mu cos 60. You know how to resolve the components. 3mu cos 60, and one more component is like this. Because see the arrow mark, how I am drawing, how am I writing. What is this component? 3mu sin 60. So 3mu, one is 3mu cos 60 left side, 3mu sin 60 upward. 3mu cos 60 left means negative x-axis. So let me write negative x-axis means 3mu cos 60 left side. So minus I cap. Left side is minus I cap. This one minus I cap. This is moving upward. Upward nothing but plus j cap plus 3mu sin 60 plus j cap. Okay, plus j cap. And see, resolve 2m into 2u also into some components. Now the momentum is 4mu. Okay, 2m into 2u, it becomes 4mu. Resolve this into two components. One component is along this direction. So 4mu cos 60. One more component is 4mu sin 60. 4mu sin 60 downwards, 4mu cos 60 leftward. So we can write 4mu cos 60. Which side it is moving? 4mu cos 60. So 4mu cos 60 is left side. Left side means minus I cap. 4mu cos 60 minus I cap plus, and 4mu sin 60 is downwards along the negative x-axis. 4mu sin 60 negative y-axis minus j cap. Okay, now you add it based on vector rules. So this P is the momentum of the resulting mass. Means what is the total mass? Total mass is 6m. Okay, so this is the resulting 6 mu. Okay, 6 mu is the resulting mass into speed is u, because target is to find out v. Okay, 6 total mass of the particles is 6 m, resultant velocity is, let us suppose, v. So our target is to find out v value, and 3 mu I cap plus 3 mu cos 60 1 by 2. So 3 mu, and here minus is there, let me write minus 3 mu 1 by 2 I cap. Okay, and this is plus 3 mu sin 60 root 3 by 2 j cap plus 4 mu, multiply plus and this one minus, so you will get minus, simplify the equations, 4 mu cos 60 1 by 2 I cap, and plus into minus 4 mu sin 60 root 3 by 2 j cap. So strike off m everywhere. Take LCM 2 here. Take this 2 and take the left side. So it becomes 12. Okay, otherwise keep as it is. So let me write here 6m into v. Take LCM 2 3s are. So everywhere u is common, you write u outside. Everywhere u is common. 3 into 2 6 I cap minus 3 u already taken out I cap plus 3 root 3 j cap minus, so 2 already taken, so 4 I cap minus 4 root 3 j cap all divided by 2. Okay, all divided by 2. So v is equals to, anyhow m already cancelled, so this is 6v. V is equals to, take this 6 right side, u by 12. 6i minus 3i minus 4i, 4 minus 3, so minus 7, 6 minus I. Okay, 7 and 6. 3 root 3 minus 4 root 3, so minus root 3 j cap. Now we got v is equals to u by 12 minus I cap minus root 3 j cap. See the answer. Okay, so the option is it is now fourth option, u by 12 minus I cap minus root 3 j cap. So this is somewhat good question. Okay, then better go for the next one. Yeah, see the next. Next one, body falling from a height of 10 meter, rebounds from the hard floor. If it loses 20% of energy in the impact, then the coefficient of restitution is. Okay, now the body falls from a height of 10 meter, so that how much it is going to lose? 20% of the energy. Once the body falls from a height something h, it is going to lose some 20% of energy. What type of energy? Generally potential energy. Okay, so it loses some potential energy means, let me write, we can write here, body falls from a height of, how much the height? It is a height of, they mentioned it 10 meter height, so that it loses some energy. Let us suppose it falls from a height h1 and rebounds to some other height h2. Here loss in potential energy is only 20%. 20% means how much now? 20 by, so 20% is lost. How much the remaining? 80%. 80% means 80 by 100, so 0.8. So the value of h2 by h1, otherwise you can write like this. So the final energy which is equivalent to 80% of useful energy. So we can write like this also, so that you will get some h2 h1 terms. So what is h2 by h1? It is 0.8. Anyhow, coefficient of restitution we know it is equivalent to h2 by h1. So 0.8, root of 0.8 value, verify it, it is approximately 0.89. Okay. So go for the next one. See the next question. A point mass 1 kg moving with velocity 8 meter per second collides elastically with a stationary point mass of 5 kg. After their collision, the 1 kg body reverses its direction and moves with a speed of 2 meter per second. The velocity of the 5 kg is, see the given point mass 1 kg which is moving with a velocity 8 meter per second. So point mass 1 kg moving with a velocity 8 meter per second, and another body it is going to strike a stationary mass of 5 kg. It is going to strike a stationary mass of 5 kg, nothing but which is at rest, and this is u1 and this is m1 m2. After the collision, 1 kg body reverses its direction. So after the collision, 1 kg body reverses its direction. It's moving opposite. Reverses its direction, moves with what? 2 meter per second. So 1 kg mass moves with 2 meter per second means this is v1. 2 meter per second. Okay, minus v1. Then what is the velocity of the 5 kg body? So very simple again, use the law of conservation of linear momentum. So what is the formula again? m1 u1 m2 u2 m1 v1 plus m2 v2. m1 1, u1 8, m2 u2 0, m1 1. v1 is minus 2 because after the collision the body reverses its direction, means it is moving opposite to the original direction. So 1 into minus 2 plus m2 5 kg and v2 minus 2 you take left, 8 plus 2 10 5 v2. So v2 is equals to 2 meter per second. See, I am getting v2 is equals to plus 2 meter per second. That means after the collision the body moving in original direction. So I am getting positive answer. So after the collision the body is moving in a original direction. Okay, take this. Yeah, okay, go to the next question. Yeah, this is also simple question. Directly we can expect the answer. A ball of mass half kg moved in a vertical circle. When ball is at a point P, then calculate its tangential acceleration. Okay, so very simple. The given ball is moving along the circumference of the circle like this. At any instant of time, P is the position of the ball. It makes something angle mentioned 30 degrees. Okay. Here, you know, there are two types of acceleration, centripetal accelerations and tangential acceleration. Okay. If m is the mass of the particle, of course they given 1 by 2 kg, no doubt weight of this body always acts vertically downwards. If this is 30 and if you extend, what is this? mg cos 30, and what is this? mg sin 30. They are asking tangential acceleration, tangent. So what is the tangent? Is the mg cos theta is tangent or mg sin theta is tangent? No doubt this one is the tangent. So the tangential force, nothing but Ft, tangential force, we can write mg sine 30. But this can be written as ma, tangential acceleration. We can write directly a as g sine theta, tangential acceleration g sine theta, but I am using some steps. Mass gets cancelled. A is equal to g sine 30, 1 by 2, g value 10, 10 by 2. What is the answer? 10 by 2. It is 5 meter per second square. Okay, so simple question. Tangential acceleration is g sine theta, actual formula. Okay, go for the next one. Yeah. Which one? Right. Yeah, see the question number 21. Remaining questions are easy. See, this will appear in 21 as well. Okay. See question number 21. A particle is placed at the origin and a force F is kx is acting on it, where k is a positive constant and if u of 0 is 0, the graph of u of x versus x will be where u is the potential energy function. Okay, so here options are given in graphical method. All options are given in a graphs. Okay, and force nothing but the given F is equals to kx. Anyhow, we used already a potential energy formula like gravitational potential energy U is equals to minus mgh, and in terms of force we already written a formula. So how we written the formula? So we know force we can write it as minus du by dx. I hope you remember this formula, minus du by dx. Just see the previous classes, every formula is covered. Okay, so du is equals to minus f into dx, f into dx. If you apply the differentiation on both sides, minus f into dx, this is u, integration of f is nothing but what? Kx dx. Integration of k is a constant, x dx is x square by 2 minus k x square by 2. So u is proportional to minus x square. It is like a parabola. If it is proportional to plus x square, maybe third option is correct. See the third graph. If it is proportional to plus x square, third one is a parabola. But according to the question, I am getting minus kx square. So u is proportional to minus x square. Then the given option is first one is correct. So first one is, see the negative parabola. So this is suitable for negative parabola. So go for the first option. Yeah, see the next question. A body of mass 1 gram released down an inclined plane describes a circle of radius 10 centimeter in the vertical plane on reaching the bottom. The minimum height of the inclined plane is, see this concept also covered. Okay, so body of mass 1 gram released down on an inclined plane that is going to be described a circle of radius 10 centimeter. I hope you remember the formula, minimum height 5r by 2. Sorry, I think radius is 5h by 2. Let me check whether 5r by 2 or 5h by 2. That I confused. Let me verify that. So the minimum height of the inclined plane. See the simple technique for this problem is, body starts from somewhere at a height h. Okay, whose mass is given 1 gram, and once it comes, it is going to describe a vertical plane. Vertical plane means vertical circle. So maybe it will comes like this. Yeah, see, same concept already covered. And here the velocity at the bottom to complete vertical circle is root 5 gr. Here you know the velocity, root 5 gr. If r is the radius of this vertical circle, then the velocity is root 5 gr. Just use the law of conservation of energy to get the answer. Here potential energy is converting into kinetic energy from law of conservation of energy. What is the potential energy at here? If m is the mass, potential energy at the highest point is mgh, and at the bottom half mv square. Okay, so gh half v square. What is v? Whenever a vertical plane, if the body completes a vertical circle, then you know velocity of the body at the lowest point of vertical circle is root 5gr. So v square is 5gr. G gets cancelled. So I hope you remember this formula 5r by 2. If you remember this formula, then problem is matter of second. 5r by 2. What is the r they given? See, again I derived. Actually, this concept already covered in the last video classes. Again I am deriving now. If you remember this formula directly, maybe this problem will take matter of seconds. So 5 into r. R how much? 10 by 2. So what is the answer? 25 centimeter. Okay. Yeah, go for the next one. Yeah, this is also easy question. See, almost in assignment sheet, most of the questions are very easy. Okay, still some questions are there. Okay, let me talk. A stone of mass m is tied to a string and is moved in a vertical circle of radius r, making n revolutions per minute. The tension in the string when the stone is at the lowest point is. See, this is also easy question, and remaining questions also very easy. Every question is a matter of 1 second, a matter of maybe minute. Okay, if you are good in formulas, you can solve each and every problem in a matter of maximum 1 minute. Okay, now I am selecting some questions, some good questions also I am selecting, and remaining most of the questions are they given force and displacement, they ask you to find work done. They given force and velocity, they ask you to find power. They given momentum and mass, ask you to find kinetic energy. So almost remaining questions that what I left in assignment sheet is, those are matter of 1 minute. Please try that questions. And let me see this question. Stone of mass m is tied to a string which is moved in a vertical circle of radius r, making n revolutions per minute. The tension in the string when it its lowest point. See, this also covered. Everything is covered. So the problem is from your side, means you have to solve. See, at the lowest point, what is the weight of the body? Weight of the body acts vertically downwards. And if speed is the value mv square by r, otherwise you can write mr omega square. Why? Because v is equal to r omega, and tension in the string is upward. Now T is equal to mg plus mr omega square. That is the final answer. But they given per minute. Per minute means you change omega value. So let me write one step here. T is equals to mg plus mr omega square. T is equals to mg plus mr. Omega means 2 pi by t. Omega means 2 pi by t, 4 pi square. Okay, 4 pi square by t. So n revolutions per minute. N revolution. So n revolutions per minute means 4 pi square by t. 2 pi by t. How many revolutions? N revolutions. 4 pi square n by t into c. You know omega formula. Let me write omega formula. Maybe you may confuse. 2 pi n by t. I hope you remember this one. T is equals to. Now let me write m outside. G plus mr. 2 means 4 pi square n square. Small n you write. N square. T square. T is 60 seconds. 60 seconds square 3600. 4 900s. Now tell me the option now. M into G plus M R pi square. Sorry, M already taken out. R pi square n square by 900. Check the option, which option is correct. pi square n square r by 900. So the fourth option is correct option. Yeah, I hope you remember the next one also, but I covered in a different way. They asked in some other way. I told you already, only the applications. See, this is also application which I already covered. A uniform rope of length L, linear density mu, is on a smooth horizontal table with a length L lying on the table. The work done in pulling the hanging part onto the table. So I hope you remembered a uniform chain of length L, mass M I given. In our concept, what I covered is a uniform chain of length L, mass M, that is placed on a table such that some part of the table is hanging from the edge of the table. Now we already calculated the work done in bringing hanging part of the chain onto the table. We got it as mgl by 2n square. I think you remember mgl by 2n square. But in our question, they given mu, linear density. What is linear density? Linear mass, you know, mass by length. So mu is mass by length. See, this is the chain. Okay, chain, total length of the chain is L. Now our target is to find out work done in pulling this hanging part. What is this hanging part? Hanging part length is given L. Okay, hanging part length is L. Anyhow, we know mu is equal to mass by length. Mass by length. Mass by length means L minus L. Okay, remaining part of length is how much? L minus L. So, sorry, they given on a smooth horizontal table with a length small l, a uniform rope of length capital L, linear density mu, is on a smooth horizontal table with a length small l lying on the table. With a small l lying on the table. Okay, the work done in pulling the hanging part. See, total length of the chain is L. From that, they are pulling small l. Still, it's not clear. There is ambiguity in a question. So, from complete length, they are pulling some length outside. What is the linear density? Mass by length. What is the length of the remaining portion? L minus L. Still, it is not clear actually. So, mass is very clear. Mass is mu into L minus L. Actual question is this, mu into L minus L. Anyhow, we know work done in bringing the hanging part, general formula mgh. I hope you remember mgh. Why I am using negative sign? Every work done we are doing against the gravity. Of course, in option there is no negative. No need to worry. I told you already, if there is no negative, then you can go for positive answer. So, m is nothing but mu into L minus L. G you keep as it is. What is height? Height, actually this is L minus L. That they how to mention clearly in a problem? Not clearly mentioned. Okay, L minus L. Okay, that is actually L minus L. Then only you will get the given option. Otherwise, it's not possible. So this is the L minus L. Okay, total length minus L. And height of this one, you know height. Height, how we can write? L minus L by 2. Height of this one, this length is L minus L. Then only you will get the hanging part. Means you will get hanging part that is moved onto the table. L minus L by 2. So, L minus L by 2 height is. Now, the answer is mu g. Okay, forget the minus. Means take the magnitude. Mu g L minus L whole square by 2. So, mu g L minus L whole square by 2. Yeah, given there is a first option. Verify it. Still question is not clear. See, after pulling it onto the table, some part is remaining. How much that length of the remaining part? L minus L is the remaining part. Then only the question is correct. So, length of the remaining part is L minus L. So that you will get height is L minus L by 2 and this is okay. Otherwise, just you go through the previous concept. Okay, I think you remembered mg L by 2n square. Okay, and I done 1 by n1 part is hanging from the edge of the table such that one more part is remaining, 1 by n2 part. I hope you remembered that is W is equals to minus mg L by 2 1 by n1 square minus 1 by n2 square. Okay. So follow the same process for this question, definitely you will get. Here the length of the remaining part is L minus L, then you will get the correct answer. Okay. Yeah, go for the next problem. Yeah, this also covered in collision, but I covered with some different numbers. So the simple logic for this question is, see, body A of mass m, B of mass 3m move towards each other with velocities v and 2v respectively from the positions as shown in figure. Along the smooth horizontal circular track of radius r, after the first elastic collision, they will collide again after the time. Yeah. See, the same model already covered, I used with v and 2v. Here they given, see, in a tube, they given some two balls. Okay. They given some two balls. This is moving with speed v, and what is the speed of the next one? This is with 2v speed. Okay. Just use relative velocity of approach before the collision, which is equivalent to relative velocity of separation after the collision. But they are asking time. They are asking to find after what time they will collide again. After what time they will collide again means this is going to strike here. So what is the relative velocity in this situation? So anyhow you know u1 minus u2 is equal to v2 minus v1. Whenever they are collide, this can be written as v minus of minus 2v. Okay, v minus, because they are going to collide. So v minus 2v. So finally v2 minus v1, we can write v2 minus v1. No need of these many steps. Directly we can write 3v. What is the velocity in this situation? 3v. They are asking to find time. Time nothing but 2 pi r by velocity. What is velocity? 3v. Velocity is 3 times of v. So direct question this is actually 3 times of v velocity. See the next. Yeah. A body of mass 10 kg at rest is acted upon simultaneously by two forces 4 Newton, 3 Newton at right angles to each other. The kinetic energy of the body at the end of 10 seconds is. Okay. See, body of mass, how much they given? 10 kg. That is at rest, acted upon by two forces 4 Newton, 3 Newtons at right angles to each other. The kinetic energy of the body at the end of 10 seconds. Kinetic energy of the body at the end of 10 seconds means we know kinetic energy as half mv square. Half m is given. What about v? How to get the v? V means we have to find velocity of the body after 10 seconds. Velocity of the body after 10 seconds. So, see how I am going to extend this problem. Here this is the body whose mass is mentioned 10 kg. It is acted upon by two forces. Okay. So, two forces which are perpendicular to each other. What is this force? One is 4 Newton, another one is 3 Newton. So, what is the resultant force acting on the body? Resultant force is nothing but 4 square, 3 square. Directly we can expect like this. 5 Newton is the resultant force because two forces are perpendicular. What is the net force acting on the body? 5 Newton. Once the net force is clear, then we can write acceleration of the body. Acceleration of the body is F by m, 5 by 10. How much the acceleration of the body? 0.5 meter per second square. This is the acceleration of the body. Once we know acceleration of the body, we can find velocity of the body at the end of 10 seconds. So, velocity of the body at the end of 10 seconds is u plus at. Anyhow, u 0, a 0.5, t 10. Then how much it is? Velocity of the body is 5 meter per second. This is only velocity, but what they are asking? Kinetic energy at the end of 10 seconds. So, kinetic energy is half mv square. Half, what is m? M is already given 10. V square is 25. So, 5 and this is 25. 125 joules. Okay, 125 joules. See the next one. Yes. A pendulum bob on a 2-meter string is displaced 60 degrees from the vertical and then released. What is the speed of the bob as it passes through the lowest point in its path? Okay. A pendulum bob on a 2-meter string is displaced 60 degrees from the vertical and then released. See, this is the pendulum, okay, whose length is mentioned how much? 2 meter, okay, 2 meter, and what is the speed of the bob as it passes through the lowest point? So once it passes through the lowest point, we know the formula 2gh. Okay, sorry, it is nothing but not 2gr direct, because it moves with uniform speed. V is equal to gr. G is how much? 9.8. R is nothing but 2. V is equals to how much you will get? 19.6. Root 19.6 is approximately, check it, 4.43 meter per second. See, I am using again shortcut. V is equal to root gr. If you want, again I will use work energy theorem. So again I will use, after some instant of time, the pendulum will reach us here. So it will cover some height h. So the same story covered in concepts. In what is h? H is equal to L into 1 minus cos theta. Again you have to substitute L value, cos theta value. Cos theta mentioned as a 60 degrees. No need of all these things. At the end you will get V is equal to root gr. You will get 4.43 meter per second. Yeah. A moving body makes a perfectly inelastic collision with a second body of equal mass at rest. Kinetic energy lost during the collision is of initial kinetic energy. Yeah, this also covered. Concept is covered. I hope you remembered kinetic energy loss of kinetic energy to the initial kinetic energy. So loss of kinetic energy to the initial kinetic energy, we have delta Ke by Kei. Initial kinetic energy is formula m2 by m1 plus m2. Got it? But they given a moving body makes a perfectly inelastic collision with a second body of equal mass. Equal mass means m2 m1 both are same. M by m plus m. What is the answer? Direct 1 by 2. Okay. Okay, now let me stop some problems today. In the next session, I will cover some more questions. Better you try to practice some remaining questions from your assignment sheet. Okay, we provided plenty of questions in assignment sheet. Most of them are very easy, no need to worry. Just you recall all the video classes and all the previous classes and recall all the formulas. Try to solve the problems. Okay, and here I covered few questions and very few good questions I covered, and remaining are direct shortcut. Means you have to remember this shortcut, otherwise it's not possible. Already concept is covered. If you are not applying the concept, means there is no use of the shortcut. Of course, previous problem also, pendulum problem also, again I used root gr direct formula. By using concept also we will get it. So better recall concepts and try to solve the problems. In the next session also, let me cover some more questions. Okay, thank you.